Welcome to this final session, guys. This course, as you may have noticed, is sprinkled with Vedic math techniques. For example, we looked at a popular technique called the Nikalam Sutra. This technique helped us multiply numbers close to powers of 100 and other bases such as 30 or 50. We also looked at a more generic method of multiplication called the Urdhva Tiryak Sutra, or the vertically and crosswise method. While introducing these techniques, I deliberately avoided talking about how they were arrived at. Basically the mathy stuff. But doing so has its disadvantages. You may be tempted to think of these concepts as tricks rather than techniques based on a solid mathematical foundation. And if you did so, it would be unfair. So in this video, we will look at the math behind the techniques. Let's start with the base 100 problem. Since we covered this technique in a previous video, I will assume you are familiar with the concept. So if you need a revision, please do so now. What is 92 times 97? After identifying 100 as the base number, let's go ahead and find the difference numbers. 92 is 8 less than 100 and 97 is 3 less. So our difference numbers are -8 and -3. We then add the first number and second difference number. We could also add the second number and first difference number and get the same result. But you knew this, right? Now we multiply this result, which is 89, with our base, which is 100. This gives us 8900. Finally, we multiply the two difference numbers. -8 times -3 is 24. And adding both these results, we get 8294, our final answer. But why does this technique work? So focus for a moment on this algebraic expression. X minus a times x minus b. This is something you would have seen in school. And solving this expression gives us x square minus bx minus ax plus ab. Since x is present in all the first three terms, let's get it to one side. So we have x times x minus a minus b plus ab. Now let's put this formula and our earlier exercise side by side. Can we transform our problem to this right-hand expression? 92 can be rewritten as 100 minus 8 and 97 as 100 minus 3. And this fits in nicely with the expression, right? So substituting the values of x, a and b, we get x is equal to 100, a is equal to 3 and b is equal to 8. Now let's replace x, a and b with these values on the right hand side. We get 100 times 100 minus 3 minus 8 plus 24. Now focus on this expression that is within brackets. Solving it gives us 97 minus 8 or 92 minus 3 or 89. And this is exactly what our base 100 method told us to do, isn't it? And the 100 maps in here and the 24 comes in from here. So our problem gets converted into a simple algebraic expression that we learnt to solve when in school. And while simple, it forms a mathematical basis to the Nikalam Sutra or our base method. Now to drive home the point, let's quickly look at another base 100 problem. What is 107 times 103? 100 again makes sense as a base, but in this case, the difference numbers are positive. Now, as before, we add the first number and second difference number. This gives us 110. And if we added the second number and first difference number, we would still get 110. Now let's multiply this result with our base. We end up with 11,000. Our next step is to multiply the difference numbers. 7 times 3 is 21. And on adding both results, we get 11,000 and 21. Now here's another algebraic expression pretty similar to the first one we saw. X plus A into X plus B. Solving this expression gives us x squared plus ax plus bx plus ab. Since x is present in all three terms, let's get it to one side. So we have x times x plus a plus b plus ab. Now as before, let's put this formula and our earlier exercise side by side. Can we transform our problem to this right-hand expression? 107 can be written as 100 plus 7 and 103 as 100 plus 3. And as before, this fits in nicely with the expression. And substituting the values of x, a and b, we get x is equal to 100, a is equal to 7 and b is equal to 3. Now let's replace x, a and b with these values on the right hand side. We get 100 into 100 plus 7 plus 3 plus 21. Now focus on this expression that is within brackets. This can be written as 107 plus 3 or 103 plus 7, both giving us the same answer, which is 110. And this is exactly what our base 100 method told us to do. And as before, the 100 maps in here and the 21 comes from here. So once again, our problem gets converted into a simple algebraic expression. The above two exercises demonstrated the Nicolet method. But in earlier videos, we also looked at the vertically and crosswise method. Here's a simple example. What is 13 times 12? So let's solve this using the vertically and crosswise method. We first group these leftmost numbers vertically and multiply them. 1 into 1 is 1. We then cross multiply the numbers. 1 into 2 is 2 and 1 into 3 is 3. We then add these results. 2 plus 3 is 5. Finally, we group these rightmost numbers vertically and multiply them. 2 times 3 is 6. And clubbing the results, we get 156, which is the correct answer. The math behind the technique is similar to what we saw earlier. It is based on such an algebraic expression. Ax plus b times cx plus d. Solving this expression, we get acx squared plus adx plus bcx plus bd. And we can rewrite this expression as acx squared plus ad plus bc times x plus bd. Let's now map this expression to our problem. Our problem statement can be rewritten as 1 into 10 plus 3 times 1 into 10 plus 2. And this can be easily mapped to our algebraic expression. This would give us the following values. A is equal to 1, b is equal to 3, c is equal to 1, d is equal to 2, and x is equal to 10. This means that we could certainly use this expression as a solution to our problem. So let's do so by plugging the values of a, b, c, d, and x. Let's now stop for a moment and compare both sides. This part of the expression matches with the vertical multiplication we did on the left. I'm going to pause for a few seconds for you to see this. Now this middle part of the expression matches with the crosswise multiplication. And finally, this rightmost part matches with the rightmost vertical multiplication we did out here. I think there are a few points to bear in mind out here. Most students find Vedic math methods fascinating because it gives us rapid solutions to math problems without diving too much into mathematical terminology. It also provides an alternative method to solving problems that is in many cases radically different from the conventional methods taught in schools. And as we saw in this video, it demonstrates that one can take sound mathematical concepts, tweak them a bit, and use them to provide quicker and more enjoyable solutions. Guys, this was our first course and we hope you enjoyed it and more importantly found it useful. We would love to hear what you thought of this course. So do send us your comments and help us make better courses in future. I am now going to leave you with a summary of what we learned so far. Thank you very much and go well.